So in the last video, I went ahead and introduced the idea of the ratio test, which is one of our more commonly used tests for convergence, as well as the idea that we usually do this with absolute values. I had mentioned I use it a lot, uh, some of it being that while it can be tough to do this with rational functions, this is a terrific test when we deal with exponentials and factorials, which, because of how Taylor series are made, happen very often. The other thing is, it is a terrific way for us to find a radius of convergence, and by extension of that, our interval of convergence. So, kind of go through the steps, and I'm going to be using the same series for both, just demonstrating ratio test as well as then using that to find a radius of convergence for the series. Is say that this is our series, and I want to use the ratio test to decide if this converges or diverges. So the idea of this is I'm going to be doing the limit as n goes to infinity, and I'm going to be doing this of an absolute value. So I'm going to say this is the absolute value of my n plus first term. So I just take my generic term and replace all the n's with n plus 1. Over the nth term, which is just this. So make that a little bit nicer looking. And x to the n over, that should be plus 1. Now, this is a little bit annoying as far as trying to read it this way. One thing to note is that this fraction bar here is division, so I'm doing a fraction divided by another fraction. So this is my limit as n goes to infinity of the absolute value of the n plus first term times 1 over, times the reciprocal of the bottom here. So now, if I group my terms kind of by like terms, this would be n plus 1 over the n times 10 to the n over 10 to the n plus 1 times x to the n plus 1 over x to the n. And working with this, well, the limit as n goes to infinity of my n plus 1 over n, I think of it as doing L'Hopital's rule. Well, this is going to 1. For 10 to the n over 10 to the n plus 1, remember that 10 to the n plus 1 means 10 times 10 to the n. So to the 10 to the n's would cancel, and I just have 1/10. X to the n plus 1 means x times x to the n. So my x to n's would cancel, and I just have x. And so what I get here is my limit as n goes to infinity of the absolute value of x over 10. Well, I no longer have any n's here inside my limit, so the limit as n goes to infinity doesn't matter. This equals the absolute value of x over 10. And so, according to the ratio test, this will converge as long as this is less than 1. If this is greater than 1, my series diverges. And if it equals 1, I don't know if it's converging or diverging. But whatever this is, if it's less than 1, it does converge. So now I can use this to talk about finding that radius of convergence. So I just found that this series does converge using my ratio test as long as the absolute value of x over 10 is less than 1. If I solve this, it will give me my interval of convergence. So to get rid of my absolute value, I just say that x over 10 is between negative 1 and 1. Multiply everything by 10. And here is my interval of convergence, which is not hard to find once we actually do the ratio test. In order to talk about the radius, though, now the distance between the endpoints, I need to take that and cut it in half. So my distance between the endpoints and cut it in half, and that's going to be my radius. Well, from negative 10 to 10 is 20. Cut that in half, and I get that my radius of convergence is 10. Kind of a second example of doing this would be if I have this series from zero, the sum from 0 to infinity of n factorial times x to the n. I would do my ratio test as n, so the limit as n goes to infinity, and I'll be using the absolute values. So n plus 1 factorial times x to the n plus 1. That's my n plus first term over the nth term. Well, n plus 1 factorial is n plus 1 times n factorial. X to the n plus 1 is x times x to the n. So my n factorials cancel, my x to the n's cancel, and I'm left with the limit as n goes to infinity of the absolute value of n times x. Well, I do have an n still in my limit, so as n is going to infinity, n times x, no matter what x is going to infinity. So this is diverging. However, we are still able to say that there is a radius because there is one situation going back here. We had said that there is a minimum interval that every power series converges on, and that's it converges at its center. So in this example here, even though my series is diverging, it still must converge at the center of 0. So its radius of convergence is 0, because from its center, there's nothing else that will converge.